Another common item that can be both rational and irrational is the square root symbol. Okay, so this symbol right here is called a square root. And here's our definition, is the square root of p is the positive solution to the equation x squared equals p. Okay, so we're going to get into more details as far as what that means here in just a minute. So the first thing we're going to do is we're going to square each number to find the first 12 perfect squares. So 1 squared is 1 times 1, which is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. And 12 squared is 144. Now I want you all to notice on our multiplication chart that all of our perfect squares, which are ones that we just found, are at a diagonal. So even as we continue past 144, we have 169, 196, and 225 if we went all the way to 15 squared. These are going to come in handy here in just a little bit. So if I were to ask you the question, what is the square root of 1? What I'm really asking you is, what number squared equals 1? Well, the number squared that equals 1 is 1. If I ask the square root of 4, I mean, what number squared equals 4? 2 squared equals 4, so my answer is 2. The square root of 9 is 3, and the square root of 16 is 4. So square root is the opposite of squaring a number. So letter A, square root of 25 is 5. Square root of 81 is 9. Square root of 100 is 10. And square root of 144 is 12. Squares that are not perfect square roots are irrational. So some examples of some non-perfect square roots might be the square root of 2, square root of 7, square root of 51. Any of these numbers are not in my list of perfect squares. So they are not perfect squares, which means they're not rational or they're irrational. Notice that perfect squares are all rational numbers. So if I have the square root of, say for example, square root of 36, that is a rational number. Since square roots that are not perfect squares are irrational, we cannot find the exact answers. They're decimals that go on forever. However, we can approximate them. So our first one that we're going to do is we're going to approximate the square root of 2. So what we're going to do is we're going to write the square root of 2 in the middle. And we're going to figure out what two perfect squares are on the either side of 2. Well, on the left side, we have the square root of 1. And on the right side, we have the square root of 4. So looking at my perfect squares, 2 fits in between the square root of 1 and the square root of 4. I know the square root of 1 is 1, and I know the square root of 4 is 2. However, my answer is not neither 1 nor 2. It's actually not even 1.5. So here's how we're going to figure this out. We are first going to look at our distance between our first square root and what I'm trying to find. And that distance between 1 and 2 is 1. We are also going to look at the distance between these two numbers. Okay, and that distance is 3. So now we have everything that we need to write a mixed number that represents the square root of 2. Since I know that my square root of 2 is going to be in between 1 and 2, that means it has to be 1 point something, or 1 and a fraction. My fraction comes from these two distances. My shorter distance here is my numerator, and my total distance here is my denominator. So I have 1 and 1/3. 1 and 1/3 is also the decimal 1.3 repeating. So if I were to put that on my number line, I would have 1, 1.1, 1.2, 1.3, and this is really 1.333 and so on. So this is going to be about right here on my number line. Okay, so now we're going to approximate the square root of 3 using the same process. The square root of 3 is also in between the square root of 1 and the square root of 4. So the square root of 1 is 1, the square root of 4 is 2. So I know my answer is in between 1 and 2. So my answer is definitely going to be 1 point something. We're going to have 1 and something in our fraction. My numerator is my distance between 1 and 3, which is 2. My denominator is going to be my distance between 1 and 4, which is 3. So I get 1 2/3, which is the same thing as 1.6 repeating. So if I find that on my number line, I have 1.5 is in the middle. So I have 1.6, 1.666, and so on is going to be about right in here, square root of 3. So if I think about this for a minute, 1 is the same thing as the square root of 1, and 2 is the same thing as the square root of 4. We see that the square root of 2 and the square root of 3 evenly divide out in between 1 and 2. So we're going to try these. The square root of 8, and we're going to approximate these to the nearest tenth. So square root of 8, the first thing we need to do is figure out what two perfect squares the square root of 8 is in between. So 8 is going to be in between 4 and 9. So those are the two perfect squares I'm going to use on either side. The square root of 4 is 2. The square root of 9 is 3. So it's in between 2 and 3, which means I'm going to have 2 point something. Okay, so for my mixed number, I have 2 as my whole number. My numerator is my distance between 4 and 8, which is 4. And my distance between 4 and 9 is 5. So this is 4 over 5. 4 over 5 as a decimal is 0.8. So my approximation for the square root of 8 is 2.8. The square root of 11. Again, we need to find the two perfect squares on either side of the square root of 11. 11 is going to be in between 9 and 16. So we're going to have the square root of 9 on the left, square root of 16 on the right. Square root of 9 is 3, and the square root of 16 is 4. So I know my number is going to be 3 and something. Our numerator is our distance between 9 and 11, which is 2. And my denominator is the distance between 9 and 16, which is 7. So we have 2 over 7. Now this may not be one that you necessarily know what 2/7 is as a decimal, so we'll do 2 divided by 7. 7 goes into 20 twice. I get 14 with left 6. And 7 goes into 60, let's see here, 8 times is 56. Well, I have 0.28. I want to round to the nearest tenth, which means that my 2 is going to round up. I have 3.3. My last one, the square root of 99, is in between the two perfect squares of 81 and 100. Square root of 81 is 9, and the square root of 100 is 10. So my answer is going to be 9 point something. My distance between 81 and 99 is 18, and my distance between 81 and 100 is 19. So my fraction is 18 over 19. This is not one that we'll know offhand, so we need to do 18 divided by 19. 19 goes into 189 times. This can give us 171. When I subtract, I'm left with 9. 19 goes into 94 times, which is 76. So I have 0.94, which is going to round to just a 9 in the tens place. So now let's look at square root of fractions. Our first fraction is the square root of 1/4. We can also just think about this as being the square root of 1 over the square root of 4. Well, the square root of 1 is 1 and the square root of 4 is 2, so my answer is 1/2. Same thing with the square root of 4 ninths. I can do the square root of 4 over the square root of 9. Square root of 4 is 2 and the square root of 9 is 3. So there's my answer. The last one, same thing. I can do square root of 16 over square root of 25, which is 4 over 5. What I want you to notice about these are all rational. I got fractions from all of these. But if I look at the irrational ones and I have to do the square root of 5 over the square root of 7, Both the square root of 5 and the square root of 7 are not perfect squares, which means that they're not rational or they're irrational. Square root of 1 and square root of 2, I know square root of 1 is a perfect square, but square root of 2 isn't, so that means that the whole thing is irrational. Same thing with 3 and 4. Even though the square root of 4 is rational, square root of 3 is not, so the entire thing together is irrational. So we're going to look at these. We need to determine if they are rational or irrational. So square root of 1 over the square root of 13 is irrational because 13 is not a perfect square. Square root of 1 over 9, both of those are perfect squares because it's going to give me 1 over 3, so this is rational. Letter G, again, both of these are perfect squares, and I'm going to get 2 over 7. Sorry about that, guys. The last one is also irrational because neither one of those are perfect, or the 13 is not perfect, even though the 25 is. 13 is not a perfect square, so it makes the whole thing irrational.